So we'll,
So I saw your that combinatrix video. I'm on lecture 2. I'm about to finish lecture 2.
okay. Uh, Once you are done the 5 lectures, I think you'll be able to solve PRMO questions.
Okay.
For example, there are quite a few easy questions in PRMO in combinatorics. Not all of them, but a few of them you might be able to solve. So first, however, we'll do Loney revision, then we'll look at actual PRMO questions from the last 2-3 years in geometry.
Okay.
So, okay, so SL Loney, so what are the things to remember? Chapter 9. Chapter 9, the identities chapter. Okay. So identities chapter, the things to remember are if A plus B plus C is equal to pi or 180 degree, right? Then what are the common standard identities that you need to know for sure? So one of them is tan A plus tan B plus tan C is equal to tan A tan B tan C, right? This we have proved earlier.
Yes.
For a triangle, this is always true. Another version of this
Yes.
is tan A by 2, tan B by 2 plus tan C by 2, tan A by 2 plus tan B by 2, tan C by 2. That will be equal to 1, right? This comes when you take A plus
Yes.
B plus C by 2 and then take C by 2 on the other side and take tan on both sides. Okay. You need to know how it
Yeah.
comes so that it is clear how you'll get it. If you forget, for example, you'll do A plus B is equal to pi minus C. You'll take tan on both sides. Tan of A plus
Yes.
B is equal to tan of 180 minus C is minus tan C. And this will become tan A plus tan B by 1 minus tan A tan B. Tan A tan B is equal to minus tan C. And then you'll be able to
Yes.
prove this one, first one. Same steps you follow except do by 2 by 2, it will become second one. Okay. This step will become cot, right? Tan 90 minus C by 2 will be cot, right?
Yes.
These two
Yes.
are important. Then there are several others, but I just want you to remember, let's say sin A plus sin B plus sin C, sin A plus sin B plus sin C, and cos A plus cos B plus cos C. That much should be enough. As long as A plus B plus C is 180 degree, these identities will be there. So sin A plus sin B plus sin C is what? 4 times cos A by 2 cos B by 2 cos C by 2. This is equal to 4 cos A by 2 cos B by 2 cos C by 2, and this is equal to 1 plus 4 sin A by 2 sin B by 2 sin C by 2. Again, the way to prove it is very simple. It is just simply take two of them together, use the sin C plus sin D formula, write it like this: 2 sin A plus B by 2 cos A minus B by 2, and so on, right?
Okay.
You remember this, no? We have done this.
Yes. Yes. Of course.
And this one will become 2
Half angle
sin
formula.
C by 2 cos C by 2, and convert this to cos C by 2, take cos C by 2 common, right? And then
Yes. Yes.
inside part you have to again simplify. For simplifying, again convert this part to cos A plus B by 2 and then add,
Okay.
right? So in the
Yes.
identity chapter, these are the main things. You don't need to memorize anything more. You just need to be able to derive it if needed. If you've forgotten something, you should be able to derive it. Then
Sir, remember I asked you a question once. It had to do with the range of the trigonometric function.
what range? Which one?
So like we had an expression a cos a plus b sine b is equal to root a square plus b square over a
Yeah, that is
by
important.
that okay, that's important as well.
But that is very obvious because you just have to divide by. So it becomes a by root a square plus b square cos theta plus. Now, the reason you get from this the range is because you can say that this is less than 1 and this is also less than 1. So you can call this sine alpha, and if this is sine alpha, this will become cos alpha. And for some unknown alpha, I don't care about the alpha value, I just care that it is possible to be written as sine alpha because it is less than 1, right? So then the whole thing will become sine alpha cos theta plus cos alpha sine theta, which is equal to sine of alpha plus theta. And
Yes.
outside there is a root a square plus b square. And since this can go from -1 to 1, this the whole expression can go from minus root a square plus b square to plus root a square plus b square, which is the range of this, right? Okay.
Okay.
Uh,
Okay.
then nothing much to remember here except the trigonometric formula general solution. C is equal to n pi plus -1 to the power n into d. Cos C is equal to cos t implies C is equal to 2n pi plus minus d, and tan C is equal to tan d implies C is equal to n pi plus d, right?
Hmm. Uh, so we're talking about the general formulas, right?
General solutions.
Yeah, yeah.
So these general solutions, three you need to know. Uh,
Hmm.
this is important because sometimes they will do things like they will give you a quadratic or cubic equation, but it will have trigonometric terms. So
Hmm.
if it ends up
And
becoming
then we need to, yeah,
yeah, if it ends up becoming a trigonometric thing,
got
then
it, got it.
eventually you will need a general solution or something. Because you might, if you don't have a general solution and someone doesn't know that, they will miss out on the roots, right? So so that is important. So that covers like till chapter 12th. That is what you need to remember. Other than the basic formula, I'm not talking about formula for sine 2a and sine c plus sine d. Those things everyone is expected to know. Everything that came before this, right? Like basic formula like double angle, half
Hmm.
angle, right? Double angle, triple
Yes.
angle. Every serious candidate is
Triangle.
expected to know those. So
Huh.
we'll not be discussing that. That you should just revise. If you have a confusion, write a chart on your room or something, put it up, keep looking at it. The basic ones, like basic ones also include sine c plus minus sine d, cos c plus minus cos t is equal to what? Is
Hmm.
equal to what? These formulas,
Huh.
right?
Hmm.
And also obviously sine a plus from sine a plus b and cos a plus b, a plus minus b, only from everything is coming, right? We have derived all of this from here only.
Yes.
You
So
remember?
I have a question. So, huh. Yeah, I do. I do. So it's in chapter 8, right?
Hmm.
It's
Chapter
in
8.
chapter 8.
What is
No,
in chapter 8? These basic
this is in
formulas are in
chapter 7.
chapter
This one.
chapter 8,
Yeah,
7,
this chapter
all.
7 and chapter.
Uh,
Yeah, yeah, yeah. I remember
before
this one.
that
Huh.
also.
So, so it's very hard for me. It's like it's very hard for me to what do you call
What?
remember all the half angle formulas.
Half angle formulas you don't need to recall. You only need to know the double and triple. How will you recall? Why is there a need to
Okay.
recall half angle formulas? As long as you know this and know this, who cares? Half angles, so you will be able to write. Just
Hmm.
replace a with a by 2.
Okay.
as long as you know these two, you can replace a with a by 2, it will become your half formulas. You don't have to specifically memorize what is sine a by 2 and all. That is not important. What is
Yes.
important to know is sine a is 2 sine a by 2 cos a by 2.
Hmm.
Convert from here, you can get half angles. That much is important. Okay. Next, we go to 12th chapter. 12th chapter starts off with sine rule, cosine rule. Those are obvious. Then it goes on to half angle formulas
Yes.
for a triangle in terms of the semi-perimeter and stuff. Those are important. These three are
Yes.
important. So this is equal to s minus b, s minus c by bc. This is equal to s minus a by bc. And this is equal to s minus b, s minus c by s minus a. Now, how do I remember it? I remember that sine has two terms and it is symmetrical. So a by 2 is there. So s minus b as s minus c will come. And denominator is bc. I mean, I remember it because I've done many questions on it, right? So it's not like,
Yeah.
yeah, there's no way or trick or anything. It's just that once you do a few questions, if you have tried a few questions of, say, exercise number uh, 30, 26 or something, 27, 27, then you will use these formulas several times there, 26 and 27. So these these two, if you remember, then obviously tan you can find out from here, right? From these two, right? Tan is just the division of,
Yes. Of course. We'll just divide them by 2. Yeah.
right?
Divide them. Right.
Yeah. So this is basic stuff. Chapter 12, there is not much to remember. These are just this much only is there. So that's fine. The main thing comes in chapter 15. So, I mean, chapter 12, sine rule and cosine rule is there, which you need to be able to write. Uh,
Hmm.
then there is properties of triangle, chapter 15. Chapter 15, area formulas are there. It starts off with area formulas,
One second.
area of
One
a
second.
triangle.
Yes. 1 second, sir. I'll just. Huh. So, do I need to do every exercise in the chapter 15 and chapter 12?
Exercise in chapter 15 will be sufficient, not 12.
Okay.
Chapter 15, exercise 36. Exercise 36, question number 5 to 27 that I have said earlier. 5 to 22.
Hmm.
And exercise 37, first as many as you can.
Hmm. Sir, and also, should I spend my time doing SL only or that geometry book, the Liu Hing one? What is it? Yeah, that the insight.
Um, it depends. Insights one is slightly tougher, but Essaloni, if you can, you should definitely spend your time doing exercise 37. Because right now, when I'm seeing PRMO questions, they are direct questions from Essaloni. Like, I will show you.
Really?
I will show you right now. So, PRMO questions are direct Essaloni
Okay.
results. It will be obvious Essaloni questions. I mean, they're not the
Sir,
same
if I
question.
can do the first. Yeah, I mean, not the same questions, but just like a variation or two of them, right?
Yeah. Yeah. So,
So if I can do the first chapter of this book, Insights book, and the and chapter 15 of Thessaloniki, will that be enough, or do I need to do chapter 2 as well?
that will be enough for now. First chapter of Insights book, and this one, no, chapter 2 is similarity. But I don't think very difficult similarity questions have come in PRMO, but uh, right now focus on making sure that Thessaloniki you know, and so you can apply it.
Hmm.
And okay, so let's just quickly finish this. So this is area of triangle in multiple ways. Also the Heron's formula.
Yes, the Heron's formula. That's where we start with.
Then you come to the special
Cosine
point.
rule and sine rule.
Before that, that exercise is quite useful, like the exercise 5 to 22 question number, right? In this, many
Which one?
people, exercise 36,
1 second, sir. 1 second.
page 192.
Yeah, 30.
In
Yeah,
this,
yeah, yeah.
all
36.
these identities are supposed to be proved, but even after
Hmm.
proving, many people remember some of these identities. Like, I will tell you which ones are nice and memorable. Like, it is good to remember some of these identities, because it's not like you'll want to prove them again and again, right? So it is good to know
Yeah,
some of them. So some of them are that I remember especially is the fifth one, question number 5. Obviously, everyone remembers del is equal to r into s. In Essaloni,
yeah,
he writes it
yeah,
as
yeah, yeah.
capital S, right?
Hmm.
Capital S
But
here.
it's del. Right? Yeah.
I mean, I prefer
Hmm.
to write it like this, but yeah, it's fine. Uh,
Yeah.
Also, that first question number 5 also tells you R1, R2, R3 formula that you will derive later, right? That is equal to del by S minus A, S minus B, S minus C.
Yeah. 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 Yeah.
So that
Yes.
anyway you
Yes.
derive later,
So,
but
but
this is important to know, obviously. Question 5 is super important to know, right? Question 7. Question 7 is also important. Question 7 is del is equal to root of R into R1 into R2 into R3. Okay. Question 7. Del is root of R. This can be proved very easily if you just do this formula, right? Apply this formula only. So see, R is what? Del by S, right?
yeah.
And
Yeah. This
R,
is just plugging in the value.
as soon as you plug in it, it will come. But it is convenient to
Yes,
know it
I've done
outright.
this.
It is convenient to know it outright, like directly you know this, right? So that is
Hmm.
important. Then not eighth one. Then the other one that is important is, see, ninth one is direct again, same derivation that we have done earlier,
Hmm.
because R1 is equal to del, in this he is saying del tan A by 2, right? By R, right? Look at question number 9. Isn't this only? See,
Hmm. Yeah,
R,
it's the same.
ah, and del by R is S, right?
Uh, 1 second. Del
From
by S is R, right?
del by R here is S.
Yeah, del by R is S. Del by
So
S.
R1 is equal to S tan A by 2.
Yeah, and then you get delta square over. Uh, hello?
You
Or
don't have to
wait.
do anything more.
Uh,
I'm just pointing out to you that later in the future sections of this chapter, or just before this section, he has derived R1 as S tan A by 2, right?
hmm.
Just before this section, turn back the page. It is R1 is S tan
Yeah,
A by 2 is there. So notice that
yes,
question
it's
number
written.
9
Yes.
is direct manipulation of that formula,
Hmm.
right? You're just
Hmm.
putting S is
Okay.
del by R, that's all.
Yes, S is del by R. Got it.
So I don't expect you to remember this form. Just remember that R1 is S tan A by 2, right? Like, we'll come to that in a bit. 1 second. Just go on to 10th one. 10th one is a nice identity. 10th one is a nice identity. It is memorable also. R1, R2 plus R2, R3 plus R3, R1 is equal to small s square. Small s is semi-perimeter. Okay. Small s is semi-perimeter. This is a nice identity that it is good to remember.
Sir, could you please repeat? I had gone somewhere.
R1 R2 plus R2 R3 plus R3
Hello.
R1 is smallest square. Can you hear me right now? Hello? Hello?
Yes, sir. Sir, could you repeat once?
Where did you go?
Sir, my mother had called me.
So you have to tell me and go. No, I am talking, you are going away somewhere.
Sir, she was like about to drop something, so I just like rushed. Sorry.
R1 R2 plus R2 R3 plus R3 R1 is S square, right?
Yes. Yes.
This you need to know for sure,
Hmm.
because I will show you a question in the book. For example, turn back the pages to page number. Uh, 1 second. It is in the miscellaneous questions at the end. Okay. So if you turn your SL only at the end, he has given a lot of miscellaneous questions. Okay, which are quite difficult to prove, by the way.
Hmm.
Around 200 questions he has given. They are quite difficult questions, but whoever does this is going to be like a master of trigonometry and geometry. So, question number 93. Look at question 93.
Of the miscellaneous one.
Miscellaneous one at the end, page number 254.
Uh, 92, 90, 93.
You can
Yeah.
see. Show
The
that
radii
the
of the three ascribed circles
hmm,
are roots of the equator. Yeah, that one.
hmm, are roots of what equation? X cube minus x square, 4 capital R plus small r plus xs square minus rs square is equal to 0.
Yes.
So
Yes.
if you can, you should remember this equation. Why? Like think about how you would try to solve this question. Show that the radii of the three, this is connecting algebra with triangles, right? Show that the radii of the three ascribed circles are roots of this equation. Right? Think about how you would go about solving this. Are you thinking?
Yes, sir. I'm I'm thinking we should look for the formula for the ascribed that
Mm-hmm.
ascribed angle radius, and then we need to do some polynomial that we need to do something with the polynomial then.
So think more. What will you do with the polynomial? What will you do? Formulas for R1 and also you know already. R1 to
Yeah, R1 is
on
S
top
tan
only
eta.
we have written na, del by s minus a, del by s minus b, and so on.
Yeah, yeah.
So what will you do then?
Say, 1 second, I'm thinking. If R1 is del S minus A,
Del by.
and so capital R is the circumradius, right?
Hmm. See, this is a
Cube
question that
minus
can
x
come
square
in. This is
times.
a question that can come in PRMO in a different form. Like people can give you, like they can give you an equation say that this are the radii, and they can give you one or two values and ask something else, right? They could totally do this. This question can be made into a PRMO question very easily. So think.
Yes, sir. I'm back.
Mhm.
I don't have.
Don't try putting any values in all, because that will obviously not work. It will be very long, no?
Yes.
That will not work, because you cannot put R1 and check whether it is working or not. It will be very difficult to simplify. So here the strategy is, this question is actually a question from exercise 26, the 36, the one that we have been discussing right now. This
So
question,
one second. One second. Let me. So I'm thinking. I need. I would. Just give me 5 minutes. Can we discuss it after 5 minutes?
I would recommend that you look at exercise 36 now.
Okay. Exercise 36. So which question?
That is up to you. Everything I should not say. No? The hint is look
Okay.
at exercise 36.
Hmm. So we need something that relates all R1, R2, R3, and R and capital R.
And S, small s.
And S. So how do you read?
How do you prove that a equation has certain roots? Like what
So
condition?
the
Uh,
so we use Vieta's relations like
so
some
use
and
beta.
some product and
So use that here.
hmm, 1 second. Okay. So if the roots are R1, R2, R3, then the sum of the roots R1 plus R2 plus R3 is equal to 4 capital R plus small r. And we know that R1 plus R2 plus R3 minus small r is equal to 4 capital R.
So that is
Then we
question
go
number
to
18.
R1. Yeah, question number 18. Yeah. And we also know that R1 now we use the second one, R1 R2 plus R2 R3 plus R1 R2 is equal to so
S
there's no
square.
coefficient of but there's no coefficient of it's equal to s square, sorry. Yeah, I couldn't see, sorry. Yeah, it's the coefficient of s square, and then R1 R2 R3 is equal to r
Hmm.
times s square. How do we do that? R1 R2 R3.
Question 7.
Yeah, and that is also in the seventh identity, the seventh question.
Because we know R into this is equal to del square. So R1, R2, R3 is equal to del square by R, right? Right? Correct. So del square is R square S square by R. So it is R S square. Correct. Hello. Are you getting how it came? Okay. So basically, that is why I said ki in this exercise, there are some nice results. So now it is up to the student. Either you remember these three or you remember this equation and remember that roots are this. If you remember this equation and roots are this, then you will be able to do Vieta and derive these identities quickly. Otherwise, remember these
Yes.
identities directly.
So
Okay.
I would remember the equation. I will remember the equation because
So it is up to you how you remember it, but you can either remember equation or remember the identities. So that is super important. One more identity in this one, which is nice, which is memorable. So you should know it, is 1 by R1 plus 1 by R2 plus 1 by R3 is equal to 1 by R. This is question number 11, right? Correct.
yes.
So, like these three, four things from this exercise are the takeaways. Like, other than that, you have to derive it. You cannot remember everything. So, these three, four things you should take away. Ki these are nice results. Okay. Uh, Obviously, you need to know all the versions of your R formulas, R and R1, like
Yes.
small r and R1, for example. R1 is the X circle opposite to angle A. So the way I remember it is this is del by S, then this formula correspondingly becomes del by S minus A because R1 is greater than R, right?
Yes.
Keeping in mind that thing helps me see the relationship between these two. So I have to divide by a smaller thing, right?
Yeah, yeah. You said that in the class in which we learned this.
So the other versions are these: sine b by 2, sine c by 2, and here it will be 4r. There will be one sine and two causes: cos b by 2, cos c by 2. One sine and two causes. Why is that? That is because this formula itself came from a different derivation where it was a by cos a by 2, sin b by 2, sin c by 2. And you had converted a by cos a by 2 to this 2r sin a by 2 by using sine rule. And the corresponding formula here was a cos cos. Everything was cos here. This formula was derived by doing BD plus CD is equal to A, if you remember, in circle. There is an angle bisector. This is my in center, and you can drop a perpendicular here. This is my D, and this is my B, and this is my C, and this is A. So this side is small a. If you do BD plus CD is equal to small a, you can write this angle as B by 2 and this angle as C by 2. You can say that R by BD is equal to tan B by 2. So R by tan B by 2 is equal to BD.
Hello, sir.
Yeah,
Hello.
yeah.
Sir, my net dropped. Could you please just tell me what you were saying?
I am saying that these formulas you need to remember. Till where did you see?
Okay.
Till
Hmm.
where did you see?
So I saw till you said you wrote down these 4 hours sin A, sin B, sin C by 2.
Hmm. So the other alternate for this is the corresponding R1 formula has two causes, and in the R formula it is three sines, and here it is two causes and one sine. How will you remember there are two causes and which ones will be cos and which one will be sine? You'll remember it because
So the one
R1.
opposite to
Uh,
the one opposite to the like R1 is opposite to A, so the one opposite to A will be the one opposite to that angle will have the sine, and the other will have the cos.
yeah, because obviously symmetry should be preserved. So if you have R1 opposite to something and there are two causes and one sine, then the one sine has to be A by 2, right? Because that is what is making the formula
Hmm.
symmetrical. Because then R2 should have one sign, that will be B by 2, right? Also, you should realize that this is coming from this derivation. From here it comes. A sine B by 2 sine C by 2 by cos A by 2. That is the derivation from which you do sine rule on A by cos A by 2 and convert that to 2R sine A by 2, right? A is
Yes.
equal to 2r sine A, and sine A is equal to 2 sine A by 2 cos A by 2. So it becomes 4r sine A by 2 cos A by 2 divided by cos A by 2, right? So
Hmm.
similarly, what you should remember is that if you remember this version of the formula, it is easy to derive this, right? And if you remember
Yeah.
this version, it is easy to remember that in the R1 formula, everything becomes a cos. Like there was
Yeah.
one cos here, it is cos 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 here, right? So because of which,
Yes.
again, there will be one sine when this is transformed into this, and two causes, right?
Yeah.
Then there was s minus a tan. Also, by the way, how does this formula come? This formula comes when you take a triangle, I is the in center, you drop a perpendicular from I, and that is called small r, and you say that this angle must be b by 2. So you must have tan of b by 2 is equal to r by bd, and therefore bd is equal to r by tan b by 2. Similarly, CD will
Hmm.
come as R by tan C by 2. And when you add these two, BD plus CD should become A, right? So you'll get R common and you'll have 1 by tan B by 2 plus 1 by tan C by 2. And that is becoming equal to A, right? And you get the R formula from here. If you bring it to the other side and simplify a little, it will come as this, right?
Okay. Yes.
So you should go through these derivations once so that you don't get confused in the exam later and all, right? Uh, the other one is s minus a tan a by 2, and here it is s tan a by 2. Again, the relation of s and s minus a is there because this has to be bigger, right? This has to be bigger. So
Yes.
multiplication is by s. Here it has to be smaller. So you must use s minus a, or you could use s minus b also. It could be s minus b tan b by 2 or s minus c tan c by 2, right? However, here since so angle and the side must match here. Cannot use s minus a tan b by 2. That will be wrong, right?
Okay.
So these are the four things that you need to remember for R and R1. Like ideally remember these two forms for sure, and this form. This form comes this form comes from doing that um, circle touches, so this length will be BD and all. The circle touches somewhere here, so this length must be S
Huh.
minus B, right?
Huh.
I will just show you once quickly. There's an in-center, so two angle bisectors, and this is an in-center, so you'll draw a circle like this, and you draw a perpendicular. This is R, this is B by 2, and this is A, and this is B, and this is C. So distance from vertex B to the point of tangency here, D, and this is E, and this is F. This distance will be S minus B. This distance will be S minus B. These distances will be S minus A. And these distances will be S minus C, right?
Hmm.
This you understand, no, why it is happening?
Yes.
Because equal tangents and all, right? And total perimeter is semi-perimeter is S.
Yes.
Now,
Yes. 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 Got it.
so now take the same triangle IBD. In that triangle, again, write tan B by 2 is equal to R by BD, right? Now this time don't do any BD plus
Hmm.
CD by is equal to A. So one formula comes by doing BD plus CD is equal to A, right? That gives you the R
Yes.
formula like this: A sine B by 2 sine C by 2 by cos.
Yes. Yes. Yes.
And same thing, uh, same thing. If you don't do that, but just write this, R is equal to BD tan B by 2, right? And
Yes.
R is equal to
So,
BD is
but
called S minus B.
huh.
So
Huh.
that gives you the other formula.
Yes. Okay.
So this is one formula. This is
So, so it becomes, so I can remember the formulas, but remembering the derivation becomes very that.
do it once or twice. Remembering derivations is more important than remembering the formula. Ultimately in the exam you'll have to do some
Okay.
tiny derivation.
Huh.
Do the derivation once more because that is
Okay.
more important actually. So remembering formulas is not the main thing here. Okay. So formulas many people can remember, but unless you know the derivations, you will not know how to approach a new question. Many people have all of these formulas in memory, and then the difficulty for them in this chapter, and this I've seen countless times, difficulty for them in this chapter is which formula should I use?
Yes, yes,
I have 15
that
formulas that I
that.
have memorized. Which one should I use? That is a sad difficulty,
Hmm.
because according to the question, you have to use, I mean, according to the question, you have to see what distances are being asked, see the appropriate triangle in which you can get those distances, and just do common sense logical steps. And that is what the derivation teaches you. Okay, what can I do here? I can write in this triangle r and b by 2 tan, right? I can write bd plus cd is equal to a also. There are two different ways in which he has gotten the same thing, right? That is why the derivation is important to remember, not for the purpose of remembering the
Yes.
formula, but for the purpose of knowing I can apply things in these ways, right?
Hmm.
So if you are forgetting the derivations, that means you need to go back and read it again quickly, because that is going to be crucial. Okay, so in center, X center, this is what it is. Uh, More results that you might discover will come in exercise 37. But for now, nothing more it needs to be memorized. That's all. Uh, then you go to the next one. Ortho center, obviously, there are many things that are nice. So you need to know stuff. Now you know also many things. So ortho center is A, B, C. I will just quickly summarize what all you know. So ABC, if you draw altitudes like this, one altitude here, one altitude here, one altitude here, and these meet at a point H. This point, let's say we call D. This point is E. This point is F, right? Now, you know many things here. The first thing that I always do is I know all the angles, right? All angles in this figure. So think through yourself. Do you know all the angles?
So as in we know A, B, and C. Huh?
All the angles you know, dude. Whatever angle you ask me, whichever angle, tell me which angle in this figure do you want?
So let's say BHF.
BHF. I know this is equal to 90 minus A, so BHF is A. Sure.
Yeah, and let's say CHE.
CHE. I know this is equal to 90 minus A. Again, so CHE is A.
Hmm.
Obviously, it was vertically opposite also.
Okay.
Everything you know. Are you convinced? What is FAH?
FAH.
Hmm.
One second. So it is we have 90, we have 180 minus A, and then we'll just subtract it.
No, tell me the answer. Don't tell me how.
One second. 90, you have one second. You're so which angle did you ask for? You asked for
FAH.
this one. F
FAH
F
will
A
be this
no,
one, no?
yeah, this one. So this is the 90 minus B.
Hmm. If that is 90 minus B, if I have to find FHA,
Hmm.
I will just say this is 90, so this must be B.
Hmm.
This is 90 minus B, no?
and this is 90. So this must be 90 plus b.
90 plus b. This must be
Huh?
b,
Oh no, sorry. Yeah, sorry. Nine.
right? So all angles you will be able to figure out, right? As soon as orthocenter is there, every angle is known, right?
Hmm.
Okay, great. Now all lengths in this figure, you know.
How?
Ask me any length, I will tell
By
you. Ask me any length.
uh, so magic. It's like he. Let's do h.
HE. H is distance. This is distance of orthocenter from one side. It is 2r cos A cos C.
How?
Distance of orthocenter from the side AC, right?
Yeah. Okay. Okay. Yeah. So that is then it's obvious because we'll just use the orthocenter formula.
Hmm.
This will be 2r HD. So I'll find HD. It's 2r. It's 2r sine b, and
Cos B
I
cos
mean 2r
C.
cos b.
Cos C.
Yeah, cos b.
What is HA?
HA is it's 2r cos. 1 second. It is 2r cos a cos b.
Nahin, HA is distance to vertex.
Okay. Yeah.
HA is distance to vertex, no?
Hmm. Yes, sir.
So that will be 2r cos A. HB will be 2r cos B. HC will be 2r cos C, right?
Yes, sir.
These results have
HB
been
will be
derived,
2r
right?
cos. Yeah. We've done this. Yeah. I'm just
But tell
like
me how to find, say, BD.
messing it. So it's S minus B.
Nahin, now you're confusing it with in circle. In circle was somewhere here, dude. वो दिख रहा था इन सर्कल था ना वो तो
1 second. Hmm. 1 second, sir. How will we find BD? So, uh, we need to find BD in terms of like
all the
A, B,
time
and C?
all the time in the triangle you are okay. It's okay to write things in terms of the variables of the big triangle, small a, small b, small c, or capital A, capital B, capital C. What are the variables of the big triangle? The sides and the angles, right?
Hmm. Yes.
All the results of properties of triangle are in terms of either this or small s or capital R or small r. That's it. Or maybe area. These are the 10 variables, no?
Yes.
So it's okay if you get it in terms of small c and all, or angles of the big
So
triangle.
what I'm thinking is this is so since this is 90 and uh,
इतना लंबा चौड़ा नहीं है. This is quite easy only. BD you have to find, no? So for what have I told you? If you need some distance, put it as part of some triangle.
yeah.
So BD is part of many triangles, but which are easy triangles for you? Which are nice triangles where you know nice
So
things?
ABD.
ABD is the easiest triangle.
Yes, ABD is the easiest triangle.
So what do you know in
So, but
ABD?
we need to know the altitude for this, right?
You know, you already know the side, no?
Yeah, we know the side, yeah.
And you don't know the angle, okay? ये वाला.
Yeah, we know B.
तो क्या है BD?
So cos B is equal to
BD by
one
C.
second. Yeah, BD by C. Huh.
So BD is
So BD is equal to C cos B.
what is CD?
So we'll take AC in this.
ACD.
Triangle AD in triangle ADC. We get cos C is equal to base by hypotenuse, which is equal to
CD by
DC by AD. So
CD by
by AB. So it's B cos C.
hmm. And therefore you get projection rule also, which is C cos B plus B cos C is equal to A.
Yes.
This is sometimes called projection rule.
Yes. Yes. It's in chapter 15 as well. Chapter 12. Yes.
Hmm. So I know BD distance, I know CD distance. I can similarly find AF. Tell me AF quickly.
So did you say anything?
I'm saying find AF and tell me.
AF.
Hmm.
One second. So, one second. Let me think which triangle to use. So it's part of AFH and AFC. So, sir, I'll take it to be part of AFC.
Hmm.
Now, one second. Give me 1 second, sir. I'll just find it out. This is equal to A. This side is equal to B, and I need to find this length. So, uh, this length is the this length is the hypotenuse. Okay. This length is the hypotenuse. This length is the hypotenuse. This length is the base. So B cos A.
Hmm. B cos A. This is B cos A. This much will be A cos B.
Yes.
So basically, all lengths in this figure also you know, right?
Yes. Yes.
Okay. So all angles and all lengths so far you know in this figure, right? Correct.
Yes.
Now we will make the
Yes. Yes.
pedal triangle by joining these 3 points.
Huh.
This is my
And
hmm.
and so we know that the in center of the pedal triangle is equal to the ortho center of the real triangle.
In center of DEF is same as H, right?
Yes.
Why? Because we know
Yes.
that each of these angles are being bisected.
Hmm.
Tell me why, how you can prove that this angle and this angle are equal? See, only if these two angles are equal, then only you can say that this is a angle bisector, right?
Yes. Then only we can say that this. We did this yesterday, sir.
Yes.
Remember? In the
I
question we did
remember.
yesterday.
Do you remember?
Huh.
True.
So I'm telling. I do remember.
Do you remember how we proved it?
So we assumed that it would meet, and then we.
No, अभी यहाँ पे बताओ. Why is it bisector? Find the angle and tell me why it is bisector. I want angle HDE and angle FDE.
Yeah, 1 second, sir.
What happened?
So I'm thinking.
Then you have forgotten, no, yesterday, whatever.
1 second, sir. Give me 1 second. So I don't remember.
So this is very important derivation. So make sure that now you remember it after this class. So this is H, right?
Huh.
So how many
Yes.
cyclic quadrilaterals can you spot here?
So HDEC.
And H, so
HDEC. H,
HFBC,
HDBF.
right?
Yeah, HFPD.
And HFAE, right?
Yes, and
Cyclic.
HFA.
Cyclic because perpendiculars are opposite, right? 90 degree, 90 degree are opposite, right?
Yes. And yeah, because they're 90 degrees and they add up to pi.
Uh, so if it, suppose now focus on HDCE, if this is cyclic, then there must be a circle that passes through these 4 points, right? Circle that passes through these 4 points. So because the circle is
Yes.
passing through these
Yes,
four
it's a
points, HE becomes a chord, right? HE is a chord and C is a point on the circumference.
yes.
Similarly, same chord will subtend equal angle here,
Yes.
right?
yes. Now I remember. Yes. Now it's yes.
So this angle is equal to this angle, and this angle to you
Yes.
earlier
Now
already
I'll remember
found.
this.
Earlier when we,
Yes, we've already found it.
it's 90 minus a, sure, na?
Yes, sure.
So this is also 90 minus a, it has come now.
Yes, this is
Similarly,
that will also be 90. This will
HF
be 90
BD,
minus B.
no, it will be 90 minus a only, no?
I'm talking about. Uh,
I am talking about the other part of that angle.
hmm. Hmm.
That,
Now we will take HF B as a that
yeah,
as a cyclic quadrilateral.
HFBD
Huh?
is cyclic and
And if we draw, then FD will be the chord.
YFD, take HF.
I sir, could you draw it separately? I'm just 1 second. Yes, sir. And now if we draw that a circle around it, around its 4 points, we get HB and FD as the two chords. So this will HDF will be equal to FBH,
Hmm.
and that will be 90 minus A. Huh.
You are getting FDH is 90 minus a and HDE is 90 minus a. So both are equal. So this is bisector.
Yes,
Total angle of this triangle becomes 180 minus, this is 180 minus 2a, right? This angle
yes,
is 180 minus 2a. So now we know that the three
yes.
angles of the pedal triangle will be 180 minus 2a, 180 minus 2b, 180 minus 2c.
Hmm.
By the same exact proof for other vertices. So what we get is the angle opposite to A in the pedal triangle will be 180 minus 2A, right?
Yes,
Angle opposite to A in pedal triangle is 180 minus 2A, right? So
yes, yes. And opposite B is 180 minus 2B.
now find the side of this triangle, pedal triangle ka side. So basically I'm asking you for DE, EF or DF.
Yes. So we'll apply a sine rule in this.
But which triangle? Suppose which one are you targeting, DE or which one are you which side are you finding? Which side are you finding? Try to find right now.
I'm trying to find AFE.
AFE.
Like F. I
Hmm.
mean FE. I'm sorry. EF. So can I just drink some water?
Why are you asking me such things, dude? You can do whatever you want. FE.
So we'll get um,
So at the choice is up to
E.
you. You have to decide which triangle to make it a part of, right?
So I'm thinking in triangle AFE because that's the easiest one in which I can spot.
AFE is easiest one because you know what in that.
Because we know AF in that.
AF you know. How much is AF? Tell
Yes,
me.
we know AF. It is
B cos A.
yeah, B cos A, and yeah, it's B cos A.
What is AE?
A is C cos B.
AE is this is C cos A, no?
C cos A, sorry. No.
Okay. You know angle also A, right?
Yeah, we know angle A. Yes.
Uh,
So if
then
if we apply sine rule, then we get EF by sine A.
you need one more distance, I think. No, then you need more
One
angles.
second. Uh, but do we? One second. Mm.
To apply sine rule, you need more angles. No, one more angle you need.
We know AFE.
You can find out. Find out and tell me what is AFE.
One second. How do we find it out? Uh, sir. Mm, One second. So what is FHE?
FHE.
Yes.
Why are you trying to find that out? You are saying it is cyclic. FHE is obviously 180 minus A, no?
Yeah, it's 180 minus A. Huh?
But why are you trying to find that out?
No, I meant FHA.
FHA.
Hmm.
I don't know. You have to tell me.
One second.
Why are you complicating matters unnecessarily? You want to find which angle? This angle, right?
Yes, this angle.
To find this angle, what do you need? Like, it is
Another angle.
very easy. It is like, do you know that this angle is 90? So this total angle is 90, right?
Yeah, yes, this total angle is 90.
So
Yes.
you need to know just this much, right?
Yeah, yeah.
And that is opposite to
Uh-huh.
this in pedal triangle half, right? It will be 90 minus C, this one.
Also, this will be, yeah, this will be 90 minus C, and that will be 90 minus 90. That will be C.
Hmm. If this
Yeah,
is A,
okay.
this is C,
Got
what is this?
180 minus A minus C. A minus C.
Which is B.
Which is B.
So what are you getting? You're getting a nice thing that AFE is similar to the big triangle
Yes, AFE is similar to the big triangle.
because this is angle A, this is angle C, and this is angle B, right? Are you sure how
Huh.
we got angle
Yes.
C?
Yes, I'm sure. We know that we just derived that in a pedal triangle,
The
the
angles are being
HD is the
bisected.
angle bisected. Yes, due to the cyclic quadrilateral. So we got that C F, and we know that CF. We know that BFC is 90 degrees. So CFA must also be 90 degrees. And now we know that CFE is 90 minus C from the pedal triangle. So we just did 90 minus C, which gives us A. And since we already know that A is a side in the triangle AFE, we get the third side as 180 minus A minus C, which is nothing but B.
So this
I'm sorry
triangle
if I said that too fast.
triangle AFE is similar to triangle ABC.
Yes.
So sides will be in some ratio, no?
Yeah, sides will be in some ratio.
So write the ratios.
So now we, one second. So it'll be one second, sir.
Hello?
Yes, sir.
Find the side.
One second. So, so I'm thinking since now we know two sides and we know all the angles, can't we apply sine rule?
But apply the easiest thing. No, easiest thing is similarity.
So for me,
For you also, it will be easy only.
one second, I'll just find it out. One second.
Do it
Okay.
by
So this
similarity.
is A. Sir, okay, I'll do it by similarity. So, sir, we know that it's in the ratio AE is in ratio with AC. So we know C cos A over
1 second.
small b.
1 second. No, that is why you don't know similarity. That is the problem. How is AE in ratio with AC? Look at the triangle and the angles right here.
Yeah. Huh?
In AFE, which side is opposite to angle A?
In AFE which side? FE.
In triangle
So it'll be
ABC,
in it'll BC or BC or small a.
should be equal to, in triangle AFE, which side is opposite to angle say B?
What's up?
In triangle AFE, which side is opposite to angle B?
Angle B AF
And in big triangle, which side is opposite to angle B?
AC.
So AF is with AC, no?
Yeah.
You were saying AE with AC.
Sorry. Huh.
AC is what?
And
AC is what? Side B.
small. Yeah, small b. Huh.
So FE is coming out to be AF into A by B, right?
Yes.
And AF is what?
AF is B cos A. It'll
B
be A
cos A.
cos A then. Huh.
So it is A cos A.
A cos. Yes. A cos A.
So now notice that in triangle AFE, all the sides are so nice. It is C cos A, B cos A cos A.
Yes.
So basically, the triangle has been shrunk by a factor of cos A, right?
Cos A. Yes.
So area of triangle AFE will be
Yeah, because you told me this that if two triangles are similar, then their area differs by a ratio of k square, where k is the constant. The ratio.
So now you can confirm that for yourself. I am predicting that area of triangle AFE will be cos square A into del, right? Now actually do the
Yeah.
calculation. This into half of sine A, right?
Hmm.
So half BC sine A into cos square A.
Yes, sir.
That is coming.
Hmm.
So right now we have found FE distance, which we wanted to find the length of the side of the pedal triangle, right? And that came out to be A cos A, right?
Yes, A cos A. Yes, A cos A, B cos B, C cos
And now you know that when the pedal triangle is formed, the upper triangles that are left out, right? Those triangles are similar to the big triangle, right?
A. Hmm.
And what is the ratio of similarity? Here it was cos A, here it would be cos B, and here it would be cos C, right?
Hmm.
Correct, makes sense.
Yes, makes sense. A cos A, B cos B, C cos A. Hmm.
So area of all of these triangles will be cos square A into this, cos square this into this, and cos square this into del, right?
What?
Area of these triangles, the top triangles, right? The similar triangles.
Huh? So could you just like 1 second? Which triangle could you?
AFE, BFD, and CED.
A F E. Yes,
BFD and CED.
and C D E. Yes.
What will be the areas of all three? Tell me. AFE to
So
just now
cos
we saw,
square.
no?
Yeah, A F E is cos square times delta.
Cos square A times delta.
Cos square A times delta. Yes. So then that B F E will be cos square C times delta.
BFD.
Yeah, B F D will be cos square C times delta.
Why cos square C suddenly? Symmetry कहाँ गया?
Sorry. Cos square B times delta.
ये सब समझ में आ रहा है कि ऐसे ही बोल रहे हो?
नहीं समझ I got confused between this triangle and this triangle. I'm sorry. And
BDE is
because C is and EDC is cos square C times delta. Why? Because C is a part in this. The symmetry is that since C is a part of this, it will be C over here, and since B is a part of this, B is will be over here.
so now you have a very nice way to find area of pedal triangle.
Yeah, we can take delta and then we can subtract all the smaller triangles.
So delta 1 minus cos square A, cos square B, cos square
Hmm.
C.
Hmm.
Correct. Now go back to
Yes.
exercise 20, the identities exercise in chapter 9 in SL
Which one?
exercise
Yeah,
20.
20.
There is a
Yeah,
formula
which
for
one?
cos square A plus cos square B plus cos square C in question 8.
Yeah, it's 1 minus 2 cos A cos B cos C.
So put that
So
here.
this will be 2 cos A minus 1. Cos A cos B cos C minus 1.
So what are you getting?
So this will be delta times 2 cos A cos B cos C.
Hmm. So that is the area of pedal triangle, right?
Yeah. So we derived it in a different way though, right?
We derived it in a different way, and that way, or direct way is also possible, right? Now look at
Yeah.
question 18 in 37, exercise 37, question 18, part 1.
Question 18, part 1. If DEF is the pedal triangle of ABC, prove that its area is 2 cos A cos B cos C. Yeah, we just did that. Yeah.
Right.
The radius of the circumcircle. is R over 2.
Okay, so part 2, how will you do?
What?
Part 2, how will you do?
So isn't capital R the circumradius
Capital R is circumradius of which triangle?
of the? Oh, okay. It's asking about the uh, uh, pedal triangle, right?
Ah,
So, so I'll do the sine rule. I'll apply the sine rule in it.
so sine rule, how will you apply? Tell me now. DEF
So
is
we
your
know
pedal
that,
triangle.
yeah, we know what DFE is. I'll take DFE.
हाँ तो वही तो है pedal triangle. There's no other choice also.
Angle DFE.
Angle DFE. Okay,
Yeah,
so
angle F. Yeah, and we know
that
this
is
is a
that is
180 minus,
180 minus 2C.
yeah, minus 2C, and DE is uh, C cos
C.
yeah,
C cos C, right?
C cos C. Yeah,
So how do you write sine rule? DE by
DE by and
sine of
sine.
is equal to 2 capital R.
Yes,
This R dash is R dash for the DEF triangle, right?
yes,
So DE is what? C cos C divided by sine of 180 minus 2C is sine 2C, right?
yeah, sine 2C, and sine 2C is 2 sine C cos C.
So this becomes 2 sine C cos C cancels. So this is coming as C by
So
2
yeah,
sine C, right? Correct?
yes, yes,
C
and
by
we know
sine C
that
is
in the real is the real 1 by R, 1 by capital R.
no 2R, C by sine C.
Yeah, 2R. Yeah, 2R.
2R by 2.
And so,
Hmm.
yeah, yeah, yeah. Now we get it. Yes,
So R dash is R by 2 has come,
yes,
right?
yes, yes.
And small r also you can get because del by S, right?
Yeah, del by S.
Right. And S you can get by just adding the side lengths, right? So
Hmm.
you can write it as 2 del by 2S, and 2S will be this side plus this side plus this side, right?
Yes,
So 2 del, area of this triangle we already have here, correct?
correct.
So you will be able to do part 3 also, no, now.
Part C is
You will be
the
able to
radius of
do it,
the
no?
yes, yes, because in circle is the intersection of angle bisector. Huh.
That's fine, but you know the
So
formula for
I
R, no?
have, yes, we do.
You are sure
So
you'll
you said you would do PRMO questions.
1 second. Right now it is not over. That's why I'm not doing it. Uh, right now you have understood this, no? Pedal triangle, everything, right?
Yes.
Okay, 1 second. I'm going to rub off whatever is unnecessary and 1 second. Correct. Okay. Now I will label some more points. Okay. So for example, I will label this point P here. Okay. Find the length of PD. Do you understand the question? Hello? Hello? Hello. 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 What happened? Threw you out. Why will you throw you out? Okay, fine. So if it is not working out, then we'll continue tomorrow then. Uh, so there is half an hour worth of more stuff to discuss here. Okay. And then we'll do PRMO questions tomorrow. Yeah, yeah. I'll send this one where I'll put it up on YouTube. So I'll send you the link. What? No, this is good class, dude. This will be useful. There's a lot of revision, a lot of stuff we did. I mean, there's no, I mean, only few times. This was one of the lower disturbances. Anyway, I'll send you the link once it is up. Half an hour worth of more stuff is there. Revise the next few pages, jo in center and all. Okay. The in center part, distance between orthocenter, circumcenter, those last 2-3 pages of 15 is left. And PRMO questions tomorrow we'll do after that is done. Okay. Bye.